Your FastMCP tools need to know who's calling them, but you don't want to clutter every function with user authentication parameters. We'll implement a clean pattern using getAccessToken to securely access user identity, scopes, and custom claims from anywhere in your tool without modifying function signatures. You'll see exactly how to extract tenant IDs, check permissions, and log authenticated actions, all while keeping your codebase dry. From FastMCP, import FastMCP. From FastMCP server dependencies, import getAccessToken, access token. MCP equals FastMCP, name equals AuthTokenDem. At MCP, tool. Async def get user info, dict. Get information about the authenticated user. Hash get the access token, none if not authenticated. Token, access token none equals get access token. If token is none, return authenticated, false. Return authenticated, true. Cliented, token cliented. Scopes, token scopes. Expires at, token expires at. Token claims hash JWT claims or custom token data. This demonstrates the dependency injection pattern combined with context-aware authentication in serverless tooling. The code shows how to access request scope dependencies like access tokens without coupling your business logic to authentication mechanics. What makes this distinctive is the clean separation between tool implementation and security context, where authentication details become just another injectable dependency. The pattern works by treating authentication as an ambient capability rather than explicit plumbing. When your tool function executes, the framework automatically provides the access token through a dependency function, while the context object handles request lifecycle management. This keeps your tool logic focused on its core responsibility, while still having access to security information when needed, following the principle of least privilege through optional dependency access. This approach solves the common problem of authentication boilerplate in RPC systems. Instead of manually validating tokens or checking headers in every endpoint, you get a standardized way to access user identity and permissions. It's particularly valuable in multi-tenant systems or when building tools that need to adapt behavior based on caller identity, while maintaining clean separation between security concerns and business logic. The trade-off is slightly more framework coupling, but the benefit is dramatically reduced authentication plumbing in your application code. Let's break it down. From FastMCP, import FastMCP. From FastMCP server dependencies, import getAccessToken, access token. Imports FastMCP for creating AI callable tools and getAccessToken with its access token type for handling authentication. These dependencies enable secure token validation and user context extraction in the tool functions. The access token type provides structured access to token claims and metadata. MCP equals FastMCP, name equals AuthTokenDem. This initializes the FastMCP instance, the core controller for AI callable tools. The name parameter identifies this toolset in logs and the admin UI, enabling debugging and monitoring. Without this, no tools can be registered or exposed to AI models. At MCP, tool. Async def get user info, dict. Get information about the authenticated user. Hash get the access token, none if not authenticated. Token, access token none equals get access token. This defines an AI callable tool that retrieves authentication status. The @MCP tool decorator exposes it to models, while getAccessToken fetches the current OAuth token or returns none if unauthenticated. This pattern cleanly separates auth state from business logic. If token is none, Return authenticated, false. This implements the early return pattern for unauthenticated requests. When no token exists, it immediately returns a falsy auth status, preventing unnecessary processing and clearly signaling the failure state. Return authenticated, true. This returns a structured response indicating successful authentication. The Boolean flag explicitly signals to callers that the user is authenticated, enabling clear conditional logic in client applications. Access token pattern. FastMCP's getAccess token. Dependency injects authentication context directly into tools, enabling seamless integration with protected endpoints while maintaining clean function signatures. The access token object returns none when unauthenticated, so always check for its presence before accessing claims. This pattern cleanly separates authentication logic from business logic, while keeping all token data available when needed.
The token that carries no data carries all data.